Okay, it's pre-calc time. So let's see what's on our plate here. Let's find the paper. That would help. So pre-calc video is being observed on Wednesday, so that should be the 7th. And our mission for the night is power reducing. Alright, so power reducing. I'm going to establish 3 more trig IDs, and again, as I develop these, they go into the back of your book after we develop them in your collection. So I need to check your collection. So bring it up to date if it needs to be. And I'm going to start with an equation that we already know, and that equation is the cosine of 2 times an angle. That was the one that had 3 different forms, so I'm probably going to use 2 of those. The first one I'm going to use is 2 cosine squared a minus 1. So 2 cosine squared a minus 1 has a power in it. It's the power of 2. And we're going to find an equation that reduces that power. So it's going to take the power of 2 and take it down to the power of 1. To do that, I need to get cosine squared a by itself. So I'm going to move the 1 over by addition and divide by 2. And that is the cosine squared of a. So, believe it or not, that is the first equation. I'm going to put the cosine squared on the left and this result on the right. So anytime I have in an expression a squared cosine and I do not want to work with a squared term for whatever reason, then I can rewrite it with that. And notice there's no squared term here. So that is called a power reducing formula. You are truly in pre-calculus because calculus is the place where that becomes very helpful. It's often difficult to find derivatives or integrals, especially integrals, of cosine squared of an angle, but it is quite possible to do that with cosine of 2a plus 1 over 2. So you're just in some preparatory exercises for calculus. All right, let's look then. What if I want to know a power reducing formula for sine squared of an angle? So I'm going to go back to the cosine of 2a, and remember I said it had other forms. Well, one of the other forms, if you check your trig IDs that we have developed, is like this. Cosine of 2a is 1 minus 2 sine squared of a. So, just like the before, I'm going to get sine squared by itself. And I'm going to take the cosine of 2a, subtract the 1 over, and divide by the minus 2. And that gets sine squared of a. Now I prefer not to work with a minus 2. I like to simplify or clean that up a bit. So let me put sine squared on the left. And when I get over here to the expression that was on the left, I'm moving it to the right. I'm going to make the 2 positive. And when I do that, that means I have taken that negative sign and I have applied it to the terms above. So it's like I'm multiplying by a minus 1 over minus 1. So the bottom becomes positive, and the terms on the top will take on the opposite signs now. So this will become negative and this will become positive. So I'm going to put the positive 1 first, minus the cosine of 2a. Alright, so sine squared of an angle equals 1 minus the cosine of 2 times the angle divided by 2. Sorry about that little blob there, just ignore that. So sine squared of an angle equals 1 minus cosine of 2a over 2. Again, that will, if you have an expression with sine squared in it, you can replace it with this expression, which has no squared term in it. You have reduced the power. And tangent squared of A is next up. And tangent squared of A is the same as sine squared of A divided by cosine squared of A, because we know tangent is sine over cosine and tangent squared is sine squared over cosine squared. But we've just developed sine squared and A squared reduced power expressions right on this page. So I'm just going to go up and take sine squared from right here and write it in 1 minus cosine of 2a over 2. So that's this. And now I'm going to write under it cosine squared from here. Cosine 2a plus 1. I'll put the 1 first. It looks nicer. 1 plus cosine of 2a over 2. So we can simplify that by flipping the bottom fraction and multiplying times the top. When I do that, you'll see the 2's will cancel out, and we will end up with 1 minus cosine of 2a over 1 plus cosine of 2a. And that is tangent squared of an angle. It is a power reducer. If you have tangent squared in your life, you can get rid of it by replacing this expression with it. Notice it has no squared terms in it, so it can be easier, can make your life a whole lot easier. So make sure you get these down in your comp book and in your equation area. Alright, I'll finish with you by using these expressions, so I'll save these over on the side. So I'm going to show you what kind of problems you'll meet to exercise this. So you'll be asked to write the expression without exponents. So the expression I'm going to ask you to write without exponents is sine to the fourth. So we're going to start by using some of these. The one that we're interested in has sine in it. So I can get this to be sine. I can rewrite this expression with sine squared in it by calling it sine squared x times sine squared x. But I can write sine squared without any power by using that expression. So I'm going to go 1 minus cosine 2a over 2 times itself. 1 minus cosine of 2a cosine 2a over 2. Alright, so those two expressions times themselves. And after that, we're just pretty much in algebra land. So 2 times 2 will give me 4 on the bottom. Wait a minute. This one, yeah, that one is under the expression. And on the top, I've got a binomial to distribute. So I got 1 times 1 minus cosine of 2a and then minus another cosine of 2a. And then a positive cosine squared of 2a. Alright, so save any algebraic questions for tomorrow, but you should be able to follow that algebra. And let's just see right here, we still have an exponent, so we're going to have to mess with that spot. So I'll go 1 minus 2 cosine 2a over 4, but when I get here, I can go over and grab my cosine squared formula right there. I'm going to write the 1 first. 1 plus cosine of 2a over 2. Oops, it's not cosine of 2a because I already started with a 2a. So what will it become? How can I follow this form? Here, a went to 2a, but in my problem, I'm already starting with a 2a in my squared term. So what will it become? So if I went from a to 2a, and I've already started in my problem with a 2a, it becomes 4a. So nothing you can't handle. All right. So now we just have algebra cleanup duty. So what shall we do? How about this? How about we divide each of these terms by 4? So then I get 1/4 minus 1/2 plus 1 plus cosine of 4a. We have 2 divided by 4, so that's like multiplying that 2 by 1/4, flipping it and multiplying it. So we're going to get an 8 under there. All right, so how's that look? 1/4 minus 1/2. And I'll just bring the 1/8 out in front like these. 1/8 times 1 plus cosine of 4a. And we want to get rid of parentheses when we can. So, distributing 1/8 plus 1/8 cosine 4a. Alright. I see nothing else I can simplify. Oh, yes, I can. There's a 1/4 and a 1/8. So that's the same as 2/8, and 1/8 is 3/8. Alright, so the command was to write this expression without exponents. So I have accomplished that. This expression right here is the same as the sine to the 4th of x, but it has no exponents in the expression. Alright, so I hope you find that quite satisfying, and that you have a satisfying rest of your evening. Have a good one. Till tomorrow. Goodbye.